Hi, my students. This week we have a new mathematics lecture, and it is lecture 5. The title of our lesson is Square Roots. This lesson is a new lesson for this year, and as you can see here, this is what I'm going to talk about. This is the form of a square root. Let us start. What are the objectives of our lesson? Number 1, define a square root. Number 2, square roots of perfect squares and non-perfect squares. Number 3, perform calculation with a square root. Addition, subtraction, multiplication, and division. Number 4, compare square roots. Number 1, define a square root. What's a square root? First, we have studied squares of numbers in the lesson powers. If I have a number, how can I get its square? The square of any number is always a positive number. So whatever the number is, when I get its square, it's always positive. My answer is always positive. The square of 5 square equal 25. Negative 5, all of its square means negative 5 times negative 5, which is also 25. 7 square, it's 7 times 7 equal 49. Minus 7, all of it squared, it's minus 7 times minus 7, which is equal to 49. So as you can see, if the base is negative or positive, always the square of it, its answer is positive. A being a positive number, there exists a number whose square is A. This number is called the square root of A. So always, what's the square root? It's the opposite of the square. For example, 5 square equal 25. Now, if I wanted to get the root of 25 or the square root of 25, I will ask, what was 25 before I make it square? So its root will be 5. The rule is radical A squared, always inside the square root, my exponent inside should be 2 to be able to simplify this square. So radical 8 square, so this symbol, we read it radical. So this is the radical symbol. As you can see, this is the symbol, it's called the radical sign. This is how we write the square root. And it is called radical. The number inside, which is A, or the base, it is called the radicand. So radical A squared is A. As I said, always the exponent inside should be 2. So I say the square cancels the radical and my answer is A. Also, radical A, all of it squared, the square cancels the radical and my answer is A. And always A is a positive number inside. Always the radicand inside should be positive. Now, 0 admits one square root, which is 0. Radical 0 is equal to 0. Please don't forget, this is very important. Radical minus A. If I have a negative base inside, directly I say this does not exist. Since I cannot get the square root of a negative number, I always get the square root of a positive number. So radical minus 16 does not exist. Radical minus 9 does not exist. Now, if I have minus radical A squared, I say the square cancels the radical. Since the minus is outside, I keep it, and radical A squared is A. For example, minus radical 5 squared, the square cancels the radical, and my answer is minus 5. Now, Square roots of perfect squares. What are perfect squares? Perfect squares are 1 square, which is 1, 2 square, which is 4, 3 square, which is 9. These are called perfect squares. So radical of any perfect square is always a, because the square cancels the radical, so always I get a. For example, if I gave you radical 36, I know that 36 is 6 square. So I write radical 6 square. The square cancels the radical. My answer is 6. Radical 9 equal, radical 9 is a 3 square. So the square cancels the radical. The answer is a 3, and so on. These are the square roots of perfect squares. We find them directly. But if we are given a number which has no perfect square, to find its square root, we decompose this number into prime factors using prime factorization. For example, radical 48. 48 is not a perfect square for any number. So simply I make the prime factorization of 48 and I write it. How do I write it? I don't write 2 to the power 4 times 3. I need to have squares. So I count 2 times, I write 2 squares. 2 times, I write 2 squared. And 3 one time, I write 3. Now I replace these prime factors inside the radical in place of 48. Now I say 2 square, it comes out as 2 since the square cancels the radical. Also 2 square comes out as 2. So now outside I have 2 times 2 times 3 cannot come outside since it doesn't have an exponent. It doesn't have an exponent 2. So it stays inside. Now I multiply 2 times 2. It is 4 radical 3. This is my answer. So what's the square root of 48? It is 4 radical 3. Another example, radical 72. I make the prime factorization of 72 and I write my answer as, it is, here I have a typing mistake. So the prime factorization of 72 is, let me correct it. It is 2 square times 2 times 3 square. So I replace these inside. Now 2 square comes out as 2. 3 squares comes out as 2. And inside I have 2. So 2 times 3, it's 6 radical 2. Now I move to the next slide. Perform calculations with the square roots. Addition and subtraction of square root. There is a very important rule in addition and subtraction of square root. If I'm adding or subtracting square roots, we can only add or subtract similar or like radicands. What does this mean? I look inside the radical to be able to add or subtract. The radicand or the number inside should be the same. For example, 5 radical 2 plus 6 radical 2, the radicand is 2, so we can add. What do? We add or subtract the coefficients of the radical. The coefficients mean the numbers outside, and we keep the radicand as it is. So 5 plus 6 is 11, and I keep radical 2 as it is. Now I have negative 11 radical 3 plus 8 radical 3, same radicands. So I say negative 11 plus 8, it is a 3, so I keep 3 radical 3. Minus 4 radical 5 minus 3 radical 5. I have same radicands, so I can subtract. Minus 4 minus 3 is minus 7, and I keep radical 5. 13 radical 7 minus 8 radical 7, the same radicand. So 13 minus 8 is 5, and I keep radical 7. So I read it 5 radical 7. Minus 3 radical 5 plus 2 radical 2 minus 5 radical 5. Who has the same radicand? It's minus 3 radical 5 and minus 5 radical 5. So I do their answer. And I keep 2 radical 2 as it is. Minus 3 minus 5 is minus 8 radical 5. Why can't I do these together? Since they have different radicands, I keep them as they are. 6 radical 2 plus 8 radical 5. Also, I have different radicands, so I keep them as they are. 6 radical 2 plus 8 radical 5, no change. Sometimes to add and subtract radicands, we should simplify them using also prime factorization. So here, as you can see, I have 4 radical 8 plus 7 radical 18 minus radical 32. I have different radicands, but I can see that 8, 18, and 32 are not prime numbers. So I can make their prime factorization. So I do the prime factorization of each one of them, and now I replace them inside the radicals. Here comes 2 outside, so 4 times 2 radical 2. Whenever I get something outside, I multiply it by the number I have it outside. Here comes a 3 outside, so I multiply 7 times a 3 radical 2. Here comes 2 and 2 outside, so I multiply 2 times 2 radical 2. Now, 4 times 2 is 8 radical 2 plus 7 times 3 is 21 radical 2 minus 2 times 2 is 4 radical 2. Now I have same radicands. So I say 8 plus 21 is 29 minus 4, it is 25 radical 2. Multiplication of square roots. Now I have rules to multiply. If I am multiplying any radical by any number, for example, 8 times radical b, I write it 8 radical b. If I am multiplying 2 radicals together, for example, radical 8 times radical b, I write it radical ab. If I am multiplying radicals with the same radicand inside, let me write it for you. For example, I am multiplying radical A times radical A. Radical A times radical A. If I am multiplying 2 radicals with the same radicand, as I am multiplying A times A is A square, B times B is B square. Radical A times radical A, the answer is radical A, all of it square. Now I say the square cancels the radical, so my square cancels the radical, so my answer here is A. So radical A times radical A, the answer is A. This is very important. As examples, let me erase them. As examples given on this, I have on these rules, I have 3 times radical 7. Applying this rule, I get 3 radical 7. 10 times radical 3. Applying this rule, I get 10 radical 3. Radical 5 times radical 2. Applying the second rule, I get radical 10. Since the radicands are different, I multiply 5 times 2 is 10. Radical 7 times radical 3, I multiply 7 times 3, the answer is radical 21. 5 times radical 6, the answer is 5 radical 6. Now, radical 3 times radical 3, it's radical A times radical H is radical A, all of it square. So radical 3, all of it square, the square cancels the radical, my answer is 3. 5 radical 7 times 2 radical 7, I multiply the coefficients. 5 times 2 is 10, radical 7 times radical 7 is radical 7 square. Now the square cancels the radical, so 10 times 7 is 70. 5 radical 2 times 3 radical 2 is the same. 5 times 3 is 15. Radical 2 times radical 2 is radical 2 square. So the square cancels the radical. 15 times 2. Also here, let me correct it. This is a typing mistake. So I write 15 times 2. So my answer is 30. So the answer here is 30. Since radical 2 times radical 2 is radical 2 square. Also, as we used to do before, if I have parentheses, I multiply everything inside by the parentheses outside, applying 1 for all. So 3 radical 2 times radical 5, it is a 3. Radical 2 times 5, it's a 3 radical 10. Radical 2 times minus 5 radical 2, I multiply. 3 times minus 5 is minus 15. Radical 2 times radical 2 is radical 2 square, which is 2. So 3 radical 10 and minus 15 times 2 is 30. This is the answer. I can do no more thing. Now, I move. If the radicand is not a perfect square, we can find its prime factorization, then we can simplify as I discussed before. These are examples for you to apply. Now, division of square roots. How can we divide square roots? If I have radical A over radical B, I can write it radical A over B, radical all of it, and I write the fraction A over B inside. Also, if I have radical and inside I have a fraction A over B, I can write it as radical A alone over radical B alone. So I can use one of these two as the given. For example, radical 7 over radical 12. I write radical 7, I write radical 7 over 12. Radical 15 over radical 6, I write it radical and inside 15 over 6. Can I reduce 15 over 6? Yes, I can reduce by 3. So I get radical 5 over 2. Radical 36 over radical 16, I write 36 as a perfect square and 16 as a perfect square. So 6, the square cancels the radical, I get 6, and the square cancels the radical, I get 4. I reduce my fraction by 2, I get 3 over 2. Also, this is another example for you here. Now I have special rules. If I have radical and inside I have A plus B, this is different. I cannot write radical A plus radical B. Why? If I have radical 4 plus 9, 4 plus 9 is 13, so the answer is radical 13. Look, if I divide them, radical A plus radical B, so radical 4 plus radical 9, it's radical 2 square plus radical 3 square, it's 2 plus 3, so my answer is 5. Did I get the same answer? No. That's why this is different from this. Also, radical A minus B is different from radical A minus radical B since I get different answers. Radical A square plus B square, I cannot write it A plus B. Also, look here, I get different answers if I do them. And radical A square minus B square is different from A minus B since I get different answers. Comparing square roots. If I have radical A compared with radical B, first I square both sides. So I make it radical A all of it squared and radical B all of it squared. For example, I have to compare radical 7 with radical 10. What I do is I square both. So radical 7 square and radical 10 square. What's radical 7 square? It's 7. What's radical 10 square is 10. Now I say 7 and 10, 7 is less than 10. So radical 7 is less than radical 10. Also 5 and radical 17. I square both. 5 square, I compare it with radical 17 square. 5 square, the answer is 25. Radical 17 square, the answer is 17. 25 is greater than 17, so 5 is greater than radical 17. 3 radical 2 compared to 2 radical 3. I square both. 3 radical 2, all of it square. 2 radical 3, all of it square. Now the square here is for the 3 and the radical. It's for everything inside the radical. So 3 square is 9, radical 2 square is 2. 2 square is 4, radical 3 square is 3. 9 times 2 is 18, and 4 times 3 is 12. 18 is greater than 12, so 3 radical 2 is greater than 2 radical 3. Now comparing negative radicals, minus radical 6 and minus radical 3. I square both. I get negative radical 6 square and negative radical 3 square. Negative radical 6 square is 6, and negative 3 square is 3. Since 6 is greater than 3, in the negative, as we go further from 0, my number decrease. So minus radical 6 is less than minus radical 3, and this is another example. Here I have a solved exercise on the rules I talked about before. You can apply it and on draft to understand the rules I discussed more. And also this is simplifying radicals using prime factorization. I solved this exercise also for you to solve it on draft to understand the rules more. Here you should do the prime factorization method. This was our lesson for this week. This is a very important lesson for next year. So please watch the video well. And after watching the video, if you have any question, contact me for any help. Thank you.